And for this next one, let's show that if x and y are non-zero vectors, then z defined as norm of x times y plus norm of y times x bisects the angle between x and y. So notice that without loss of generality, we can assume that x and y are not scalar multiples of each other. Because if they are scalar multiples of each other, then z defined this way is a scalar multiple of both of them. And so they're all three vectors on the same direction, and there is nothing to prove because the angle between them is 0. So let's just assume that x and y are just pointing two different directions. For example, I can put this to be my x, and let's say this is my y. Great. So let's first think geometrically. So if x and y, let's first suppose for a moment that x and y are of the same length. So say y just stopped here. Then if I draw the line between my x and y, this is an isosceles triangle. And therefore, the angle bisector here, some z, this will make a right angle with my line here, and it will also bisect my line, which means the length of here is equal to the length here. It's the intersection point is exactly the midway from x to y. Great, so let's now make x and y the same length. So how we do that, we can rescale we can rescale y. So consider norm x over norm y times the vector y. Let's set this to be y prime. Then what is the norm of y prime? This is just equal to norm x over norm y times the norm of y. But these cancel, so we're left with norm of x. Therefore, my y prime here has the same length as x, but they're just pointing in two different directions. So now we have vectors x and y prime. How can I find the middle point? So the middle point of x and y prime is just x plus 1/2 of y prime minus x. And this is just equal to x plus 1/2 y prime minus 1/2 x. So this is 1/2 of x plus y prime. And we can calculate this explicitly. So the midpoint of x and y prime is 1/2 times x plus norm x over norm y, y. And this is this vector. Let's call it m. So if my vector z is a scalar multiple of m, then z bisects the angle, right? If z is equal to lambda m for some lambda not equal to 0, a real number, then z bisects the angle. But then recall what is our z here? This is norm x, y, plus norm y, x. But this is exactly equal to 2 times norm y times m, right? Because 2 times norm y times 1/2 of x plus norm x over norm y, right? So the 2 cancels with this 1/2, and so we're left with norm y x plus, and then norm y here cancels with the norm y in the bottom, norm x y. And this completes the proof.